Hey guys, how we doing? We are starting chapter 12 here.
Yes,
Really,
sir.
we're not jumping very far.
Nope.
Hopefully,
Two-dimensional 3.
yeah. Hopefully you did well in the last chapter. The last chapter was doing area and so on, and like we talked about at the beginning of that chapter, you've been doing that for years, really. And so, really, what we're doing is just taking those kinds of shapes and making three-dimensional shapes out of them.
Yeah.
And so, part of what we're doing is actually exactly the same thing.
Yeah.
Adding up those shapes and so on to create or calculate the area of a three-dimensional shape, surface area it's called. So, but to get into there, we need to first start just kind of some vocabulary here
Right.
of what we're even talking about.
And it's super important that you get this.
It is.
You know, because this is where, a lot of places where I see kids just make simple mistakes because they don't get these basic ideas.
Because actually a lot of these terms are new.
Yeah.
Even
yeah.
though a lot of the chapter is stuff they've been doing before, but
Right.
these terms are new. So
Right.
yeah, you guys, you do need to catch these terms here and understand what we're talking about, because just like every other chapter, we discuss vocabulary in the first section, and then we use that vocabulary the rest of the chapter.
Yep.
So you got to know what we're talking about here. So, and really what we're talking about is naming three-dimensional shapes here.
Yep.
And so they're actually called polyhedra, kind of like polygon, with the many. And so polyhedra is just a three-dimensional shape, but what makes up the shape is polygons.
Yep.
Has to be polygons put together in order to create that three-dimensional shape. And so we can have prisms, and a prism is basically what's pictured here. A prism is kind of almost like a rectangular type box, typically. The sides could be trapezoids like this one, but typically when we say a prism, we usually mean a rectangular prism.
Yeah.
Not always, of course, but and then a pyramid would just, if that top of that shape wasn't cut off, and you think about the pyramids in Egypt, if that top of that wasn't cut off and it came up to a point, that would be a pyramid. And so to where there would only be one base and a vertex point at the top. Prism has two bases, that pink one and the bottom one that it's sitting on in this particular example. And so, again, so a polyhedra is a polygon solid. It's a three-dimensional solid. All the sides are some type of polygon from last chapter, actually from chapter 8, when we talked about the different shapes and so on. And then we found their areas in the last chapter. So just like a polygon, you can't have any curves to it, no curved sides. They do all have to connect, and only at the end points. Some of the specific vocabulary terms in this particular diagram here is the face. So each of the sides of the box here are called faces. Where the faces come together, those are called edges. It's not real clear there in the diagram, but an edge is kind of like one of the sharp edges you would think of to where the faces come together. And then, of course, a corner is still called a vertex. We've had a vertex ever since the beginning of the year. Vertex is a vertex. And then we don't really get into the names of polyhedra too much like we did in the last couple chapters, but we will name the polyhedra using the whatever base it's sitting on. And again, if it's a prism, it'll have two bases. Typically, those bases are the same shape, and then a pyramid. And so maybe we'll have like a hexagonal pyramid because the base is a hexagon. And so that's how we'll end up naming these polyhedras based on what their bases are. So.
And sometimes what like kids will get kind of weirded out by seeing a triangular prism, and they'll think that well, one of the rectangles in there has to be the base because that's what rectangles always are, our bases. And just remember, guys, we're looking for two congruent shapes in there, okay? And they're usually parallel to one another,
Right.
And they're going to be those two pieces in there that are exactly the same. If there are two pieces in there that are the same and parallel, usually those are going to be the bases, and that just kind of throws kids off sometimes. But
Yeah.
this is a lot of fun for me. I like this.
Oh yeah,
chapter.
three-dimensional shapes are great.
Yeah.
You know, another problem that a lot of students have with it though is trying to draw them.
Yeah. Oh yeah.
Trying to draw it can be challenging.
Yep.
Because you're trying to draw a three-dimensional shape
Yep.
on a two-dimensional piece of paper.
Yep.
And so it does make it hard, and so you kind of have to see where the dotted lines are going, that the dotted lines are always behind, like in this case it's that back corner back there, and be able to draw those in and kind of see where things go there. And so so it's good. We're kind of doing an art lesson here too.
Yep. Go see
Trying to
Mr.
do some
Sharp
drawings.
if you need help.
Yeah. Yeah. Yeah, so is that it for that one?
So for that one.
Okay.
So now, if we're still talking about name, we want to name a polyhedron here and tell the number of faces for F and vertices for V, and edges with E. And so based on the information you have here, you can kind of look at this. And then, so if we're looking at this now, this one could go a lot of different ways here, depending on the edges. But when you see all these different rectangles in there, this is a rectangular prism, that first one. And so if we want to count all the faces, guys, okay, it's 4 around the top, or 4 around the outside, and then 2 on the ends. And so that gives us 6 faces. The vertices are all the corners. Okay, so you've got 4 on the front rectangle and 4 on the back rectangle, so there's 8. And then the edges, okay, the edges get a little bit bigger because you've got 4 on the front rectangle, 4 on the rectangle in the back, so now you're at 8, and then another 4 going on all the way around the shape of the part that's stretched there, so you have 12. Okay, and so there's your rectangular prism. Faces are 6, vertices are 8, and edges are 12. Okay, and so there is a theorem that you could use to kind of help figuring out some of these things a little bit easier, and it's called the Euler's theorem. And
Or Euler's theorem. You can call it either way.
yeah, and
It looks like it's Euler's theorem, but it is pronounced Euler's after the mathematician that discovered it.
Mr. Scritchfield taught me
Yeah.
the correct way.
But there'll be problems with this.
Yeah,
They'll give you
2 of them are one.
this particular shape has this many faces and that many vertices. How many edges are there, or whatever?
Right.
And so you kind of have to have this formula.
Yeah, and so I mean, if it's easier to find one of them and then find another, then you can go back and find the third piece by just converting the formula. Like if we look at this triangular pyramid, hexagonal. I'm sorry, base.
Yeah, the base.
So there you go. I made my mistake right there. So it's a hexagon on the bottom. So this is a hexagonal pyramid. All right, and so if we wanted to figure out, an easier way to figure this out, because a lot of time the edges, there's a lot of edges, okay? And so if you look, there's 6 triangles in there, okay, plus the base on the bottom, so you have 7 faces. And then on the vertices, you've got 6 along the bottom and then 1 on top, so there's 7 there too. So if I do that and I go 7 plus 7, and then I subtract 2 from that, then I should have 12 edges. Okay, and so that's just an easier way to do that. Sometimes if you don't want to take the time to count everything up, you can count 2 of the pieces and plug it into the theorem there and get to your answer quicker. I mean, it's pretty straightforward.
Yeah.
And then the last one, well, we can't do anything with that, guys. It's not even a polyhedra.
Yeah.
So,
Got curved edges to it.
a little trivia for you, Mr. Scritchfield. Do you know
What's
what the correct name of a soccer ball is?
I don't. Is it
Truncated dicosahedron.
really?
Yeah.
There you go.
My geometry
Learn something
teacher
every new.
taught me that in high school.
Say it again.
Truncated dicosahedron.
Truncated dicosahedron.
Yeah. So,
Alrighty then.
what that means? It means a soccer ball.
I'm trying to think of what is a dicosahedron.
That's what he
It's
told
not
me.
20,
So yeah,
right?
yeah. So I think there's 20, maybe 20 hexagons in there and 20 pentagons.
Interesting.
So,
Good.
anyways,
It's good.
yep.
That's it.
That's
That's
it.
it for this section. All we're doing is just talking about the names of these things and how to find, and really it's just counting.
Yeah.
Faces, vertices, and edges.
Okay.
So, all right. So we'll practice some of this in class.